for parametric curve. Okay, so I must have given you formula earlier also. This equation, this is the formula which we are going to use. Okay, for parametric curves, this is how we write down parametric curves. X and y are some function of t, isn't it? Third parameter, the parametric function bane. So parametric curves ko formula yo bhayale half t1 to t2 means change in t. Everything will be in terms of t. Hamro function pan t ko terms ma, integration pan t ko terms ma. So you see, hamro formula apply garnuko lagi, you need to differentiate x and y with respect to t first, and then use it here, and we will calculate. Then we will integrate to get the result. Okay, so there is one question where we will apply this formula directly. In this question. Okay, so you can see these two functions are parametric functions. This not two, one function. You can say this function is parametric function. X is some function of t, y is some other function of t, and t is ranging from -1 to 1. It's already given. I know t value given, sir. So we need not to worry about limits of integration. So we need to find out area under this curve. So formula we have just discussed, this one. Okay, your formula use garnako lagi we have to go through a little bit of lengthy process. This differentiation part, you have to apply quotient rule. So process only lengthy answer, I know, but it's something which you can do. I know I differentiation garna it is going to take almost half of the period. Answer, but you can easily multiply it with x and with y and then subtract, and finally you will get one expression for within this bracket. I know, so that expression will be, I will be giving you direct result. And cross check you will get t square minus 1 over t square plus 1 whole square, and then we have to integrate this function. I would say our function of integration is this. With respect to t, we are going to differentiate. So can you tell me how to integrate this function? T square minus 1 over t square plus 1 whole square. How to integrate this? Anybody?
X is equals to tan theta गरेदेखि हुन्छ कि?
Yes, very good. Put t equals to tan theta, है ना? So t को ठाउँमा tan theta राख्न साथ, you see this expression converts to tan square theta minus 1 over tan square theta plus 1 के हुन्छ? Cos 2 theta, isn't it? So cos 2 theta को whole square हुने भयो. So that's how you are going to integrate this. And your limits of integration is already given, -1 to 1 integration of this function. Now we are changing this limits of integration from -1 to 1 to 0 to 1. Yes, let's say 0 to 1 बनायो. 0 to 1 बनाइसकेपछि कसरी बनायो? Yes, very important question. I will not tell you, you will tell me. How can we convert in this integral? How can we convert this limits of integration from -1 to 1 to 0 to 1?
2 ले multiply गरेर.
Very good. By multiplying it by
symmetric integral.
Yes, exactly. I know 2 times gore bhane you can convert it to 0 to 1 because your f of t here is even function. Okay, it's a even function, that's why. Yeah, odd function भएको भए सिधै 0 integrate गर्नै पर्दैन, सिधै 0 राखिन्थ्यो हैन. So now we have to simply integrate. So integration गर्दा फेरि screen hang भयो. So I have already mentioned that here when you replace it by t equals to tan theta, so you will get cos 2 theta whole square, and tan theta la तिमीले t assume गरे हैन, tan theta equals to t. My screen is not moving, that's why I'm doing this. It will take a little bit of time. So tan theta equals to 2t. So when you differentiate, you will get sec square theta d theta equals to dt. So dt को ठाउँमा के आयो sec square theta d theta. All right, limits of integration, you know, it will be 0 to pi by 4. Now you see you can convert this cos to theta in terms of cos square theta. यसलाई cos square theta को term मा convert गर्न सकिन्छ. अनि तिमीको you can multiply it by sec square theta. The few terms gets cancelled and you will get a very simplified integration to do. Okay, एकदम सजिलो भएर आउँछ. Now यसपछि हामीले rectification गर्नुपर्ने. Let me open it again. In rectification, so area hamro complete bhayo, area under the curve. So till now you were just aware that application of integration is to find out area under the curve, but we can use it in many other ways also. We can not only find out area under the curve, we can also find out length of the curve. Okay, length of the curve. So now let's see how to find out what logic is applied when you find out length of the curve. So suppose this is any curve. This is any curve. And what is your aim? Your aim is to find out length of this curve from A till B. Okay, A देखि B सम्मको length चाहियो of this curve. So let us assume that this curve is formed by a wire. एउटा वायरले यो curve बनाएको छ. त के गर्दिने त्यो वायरलाई चाहिँ stretch गरौँ. Stretch it by after holding it from point A and point B. Hold it from point A and B and stretch that wire. You will get a straight line, and that's what you are looking for. You want to find out length of that straight line. Okay, so that means length of this curve. So let's do one thing. Let's apply a few logic. यसो experiment गरेर हेरौँ कसरी आउँछ होला हाम्रो length of this curve. So let's first of all let's do one thing. Let's join these 2 points by a straight line. एउटा straight line ले join गर्यो. So do you think this is going to give you a good approximation of the length of the curve? Yes, what do you say? No, definitely you can clearly see that it's far away from your actual result. Now let's do one thing. Let's divide it into 3 equal parts. 3 equal parts. And now let's find out these. Let's add these 3 equal parts and find out the length. What do you say now?
पहिलाको भन्दा चाहिँ अलि नजिक दिन्छु.
Yes, a little bit better than previous one, I know. But again, let's do one thing. Let's divide it into many such small parts, many such small equal parts like this, like this, like this, and this. What about this now?
Even better than last.
Approximation. So that means what are we observing? That we are reaching very close to our actual result. So how are we going to get our actual result? When we divide this curve into infinitely small such straight lines. Okay, so when we join these two these 2 points of the curve by infinitely many such small lines, and find out the length of all these lines and add it. हैन पहिला सबै लेन्थ फाइन्ड आउट गर्ने अनि त्यसलाई A देखि B को जति पनि इक्वल इन्फाइनाइटली मेनी लाइन्स छ त्यो सबैलाई एड गर्यो भने यु आर गोइङ टु गेट द एक्चुअल लेन्थ अफ दिस कर्व हैन. सो हाउ आर वी गोइङ टु डु दैट? For that I am taking one of this infinitely small length. In this rectification we are using this S symbol for length of the curve. Okay, so to find out we are looking for length of the curve. So त्यसलाई हामीले a capital S ले denote गर्यो, but small infinitely small length we are denoting it by ds only. So how do you find out this ds? Okay, you see you say एकदम infinitely small छ तर because I have to show you what actually is happening, so I have enlarged it and showing it to you. So this yellow line is the infinitely small that line, and then dx is the small change in x, this small change in height is y, dy. So what is going to be your ds in terms of dx and dy? You can clearly see,
root under dx square plus dy square.
yes, exactly, na? Pythagoras theorem. When you take ds equals to root under dx square plus dy square, let's take dx square common out of this under root. Dx square हमने common लिया तो you are going to get the 1 root under 1 plus dy by dx square dx. Okay, this is your expression you are going to get for ds. So अब यो ds भनेको सानो length choice, infinitely small length. But what actually we require length from a till b. A देखि b सम्मको length चाहियो. So how will you get it? Now you know. What will you do to get the entire length?
Integration from a to b.
Yes, exactly. Now you are going to integrate from a to b. That means you are going to add all the infinitely many lines in between a and b, and you will get the actual length of the curve. Okay, so यही हो हाम्रो rectification का लागि formula. So this is going to be your first formula for Cartesian curve. For Cartesian curve, this is going to be your formula, root under 1 plus dy by dx square dx. So now you know that how this formula is formed. So let's change the scenario and tell me what will be your formula in that case. Suppose your curve is something like this, and your limits of integration is a to b, but this a to b this time is change in y. Okay, so that means your curve is something like this. A देखि b भनेको change in y छ. So in this case, what change you are going to make here in this formula? यो formula मा के change आउँछ त?
Change in dx and dy, interchange of dx and dy.
Exactly. Interchanging x and y. So here you will get dx over dy. Just interchange your x and y, and here you will get dy in place of dx. You will get dy. That's it. I know. यति गर्न छ तिमीको formula change भयो according to your need. Okay, limits of integration is change in y. Now similarly you will have formula for polar curves and parametric curves. So polar curves, your formula is theta 1 to theta 2, means because polar curve मा तिमीको function theta को term मा छ, so you will have everything in terms of theta, हैन? So d theta भनेपछि theta को respect मा integration हुन्छ. So theta 1 to theta 2 change in theta values, and your function will be root under r square plus dr over d theta square. For parametric curves, you will have dx over dt square root under plus dy by dt square into dt. So because every function is in terms of t, so limits of integration is change in t. Okay, this is for parametric curves. Now let's use this formula. यो जुन dy को term मा छ नि, dy को term मा. Okay, we will be using this formula first of all. So this is going to be your first question. This is your first question. Find the length of the arc of the parabola. This, your parabola is x square equals to 4ay. So your plotting will be this. From the vertex to an extremity of the lattice rectum. So तिमीलाई कुन length चाहियो? You are looking for length from vertex to the extremity of the lattice rectum भनेको यहाँसम्मको length. Vertex lattice rectum सँग meet गर्ने सम्मको length. That means from 0 0 to 2a, 0 हैन? यो तिमीको point lattice rectum सँग intersect गर्ने point के भयो? 2a, a. Okay, so now either you use, here you have choice. तिमीले x को respect मा गरे पनि हुन्छ integration, y को respect मा पनि. So x को respect मा त हामी गरिरहेको हुन्छ. Let's do it with respect to y. So your integration in terms of y will be this. Okay, y को term मा गर्दा फेरि तिमीको formula यो लाग्छ 1 plus dx over dy square dy. So you need to calculate dy by dx over dy first. So this is your function of integration. This is a function you are dealing with. So you will differentiate with respect to y. you will differentiate this function with respect to y. You will get your dy by dx, sorry, dx over dy, 2a over xi plus में हो minus में. ठीक sir. Okay. So now we will just apply your formula now. Our dx over dy रख देने, 2a over x square it, and limits of integration. Yes, what will be your limits of integration here? Limits of integration, very important. Yes, come on.
0 to a.
Very good, 0 to a. Because here you are integrating with respect to y, so you will look at change in y. तिमीको y कति कसरी change भइरहेछ. So you're looking for length from this point till this point. यो दुईटा point को बीचको length चाहियो. तो यो दुईटाको point मा हेर्दा फेरि y coordinate changes from 0 to a, so your change in y is 0 to a. All right, so that's going to be your limits of integration. This 0 to a, and integration part is easy. Definitely, I will leave it for you. So just simply, किनकि हाम्रो y को respect में integration भइरहेछ, so you will change your function in terms of y. So replace your x square as 4ay. Have you seen such type of equation before? Have you seen this type of equation before? What was the name of that curve?
दुईटैमा ए हुँदाखेरि चाहिँ एस्ट्रोइड थियो.
Yes, it was asteroid, isn't it? So asteroid. Okay, so this looks somehow similar to asteroid, but not exactly asteroid, because यहाँ चाहिँ a र b दुईटा different values छ हैन. So asteroid र hypocycloid मा के difference भयो त? What do you think? हामीले asteroid, we were talking about all the conditions of asteroid. Asteroids को हामीले जब conditions, yes, conditions decide गरेर, in that case we observed that your conditions of asteroid was exactly similar to which curve? Asteroid को
सर्कल.
we very good, circle हैन. So asteroid को conditions सबै circle सँग similar थियो. यहाँ hypocycloid को conditions सबै कोसँग similar हुने भयो त?
Ellipse सँग हुन्छ.
Exactly, ellipse. I know, because you see x and y intercept are different in this case. So एउटा मात्र difference asteroid र hypocycloid मा त्यो चाहिँ x र y intercept फरक हुन्छ भन्ने कुरो भयो हैन. So you can clearly see when I enlarge this, you can see that your x intercept is 4, 0 and minus 4, 0. Your y intercept is 0, 2, 0, minus 2. Okay. So that's your hypocycloid. Okay. Now let me just, for the sake of our ease of integration, we are going to do one thing. We are going to convert this this function from Cartesian form to parametric form. के भयो कि हामीले यसलाई parametric form मा convert नगरेर, if we keep it as it is and go for integration, तिम्रो integration becomes very tedious. Okay, यस्तै यही equation लाई consider गरेर हामीले Cartesian को formula लगाएर गर्यो भने it becomes tedious. So what are we going to do? We are going to convert this equation first into parametric form, and then we will apply formula for parametric form. Integration सजिलो भएर आउँछ. Okay. So for that, let me give you a hint how to convert it into Cartesian form, sorry, parametric form. So you remember what was equation of circle in parametric form? You must have mentioned, हाम्रो class में discuss भएको पनि हुन सक्छ है. This was your equation for circle. Circle को लागि हैन. Now we want to convert this equation from circle to ellipse. So ellipse में convert गर्नु पर्यो भने you will make only one change, that is y को अगाडिको constant will be different. Yes. Now what will be your equation of hypocycloid in parametric form? May take help of this.
cos cube र sin cube हुन्छ होला.
Exactly. Very good. You're going to have cos cube and sin cube. That's it. कसरी भयो? You can see What does it imply? It implies that x by a is equals to cos cube theta. So let's eliminate this cube. Cube eliminate, what will happen here? You will get x by a to the power 1 by 3, isn't it? Now your cos ka lagi bhayo, sin ko lagi kyun nahi? Sin theta will be y by b huncha, that's it. So now you square cos sin, you square both equations and add, you will get hypercycloid. Clearly? Okay, ठीक sir? So your equation in parametric form is this. This is your equation in parametric form. Now you have to find out perimeter of hypercycloid. अब ये hypercycloid को हम लोग चाहिए perimeter. What happened? You want perimeter means total length. Okay, before we move on, let's decide on limits of integration. हम इसमें equation ऐसा क्या hypercycloid को, and always remember that we take minimum possible limits of integration. So what will be change in theta? Let's talk about only first half length. First half को length मात्र, let's find out length from here till here only. So can you tell me what will be your change in theta for first quadrant points of hypercycloid? Hypercycloid को सभी points, first quadrant को points, theta को कौन value को लगे आऊँ sir? What all values of theta gives you these points?
0 to pi by 2.
Very good. 0 to pi by 2. Yes. Same circle में अपन same question है ना? 0 देखिए pi by 2 रखना साथ you get all the points of first quadrant. So when you put 0, theta 0 रख द फिर you can clearly see here it happening also. You can clearly see that when you put theta equals to 0, you will get 0 a comma 0. And when you put theta equals to pi by 2, you will get 0 comma a. In case of circle, in case of ellipse, you will get 0 comma b. Accordingly. So similarly, hypercycloid के केस में अपने same नहीं सा है, तो अब तिमीले asteroid को लाइए पनि सकिन्छ. If you have to do it for asteroid, then also you can do. Now, what is your formula which we will be applying? Total length को लागि, because this is parametric curve. So this is your formula for parametric equation. Okay. अब यो formula apply मात्र गर्ने त हो नि हैन? So we require dx over dt. In other than I've used here place of theta I've used. So dx over dt, dy by dt, we have done calculation part, and then we will put the values here. Okay, put it here and then simplify. So when you will simplify this equation, so your dx over dt is this, dy by dt is 3b sine square t d cos t. So there is nothing to explain here, differentiation part. You know, our duty terms my square गरेर add गर्दा फेरि few terms will be common, and that few terms will be 3 square cos square t square, sorry sin t square, 3 square sin square t cos square t. So we will take it out of under root को बाहिर लेख्दा फेरि we will simply get 3 sin t cos t. Okay, so this is common. This term is common. So what is left within bracket? This term, a square cos sin square. Now, how will you integrate this? Just in one assumption, we will get the result easily. But what will be that assumption? I need to mention limits of integration also. What will be your limits of integration? Sorry, what am I saying? Substitution part. Can you tell me what will be your assumption that gives you, that helps you to integrate this function? Anyone quickly? Come on. यहाँसम्म कसैलाई डाउट छ? Yes, how will you integrate this function? Okay, nobody can come up with this substitution part. So let me guide you. You have to substitute this equals to y. That's it. You see, when you substitute this equals to y, what are you going to do? What are you going to get? Differentiating dy will be equals to cos 2 times of cos t sin t, 2 times of sin t cos t. Okay, or definitely there will be certain constants. So this is going to be your differentiation part. And the differentiation go your expression also, and you can clearly see that sin t into cos t into dt is dy in terms of dy. Okay, that's it. Just integrate now. Integration there is also you have to integrate just simply root y into dy. Any doubt? I will explain this question, and solution part you can just check on your own. Lots of process, but lengthy, halka lengthy jansa to hernu paryo. Okay, so what is the question here? If S be the length of an arc of the curve, this a cursor, this look at this curve, 3ay square equals to x times of x minus a square. So your curve is a loop. This is your required loop. Your loop banira satimko your equation le. You can trace it on your own. Measured from origin to the point x comma y is your length s. Okay, so what does it says? That if s, you can see it in here. If s is the length of this curve, using s, it denotes the length of the curve from origin to any point x comma y. Kune euta point sammako length ho. Now you have to find out. No, you have to show. You have to show. Square. Here we have a square also. Okay. You have to show that 3s square is equals to 4x square plus 3y square. So this is what you have to prove. Okay, and also you have to show that length of this entire loop. Your loops are your loop whole length. Okay, so that means you will find out length from 0 to a and then multiply by 2. That whole length is also equal to this. So you have to prove this also. Okay, so हमले सबभन्दा फर्स्ट स्टेपमा त यो हामीले यो एक्सप्रेसन प्रुभ गर्छ माथिको एक्सप्रेसन. यो माथिको एक्सप्रेसनमा जुन s छ is its length from origin to any point x comma y. So how will you use this expression to find out length of the entire length loop? यो total loop को length find out गर्नको लागि how will you use this expression?
तो यसलाई इन्टिग्रेट गर्ने.
हजुर.
तो यसलाई चाहिँ 0 बाट a सम्म इन्टिग्रेट गर्ने कि तो यक्स छ नि
2x 0 देखि a सम्म इन्टिग्रेट गर्ने. ओके, सो इन्टिग्रेसन पार्ट हामीले पहिले गरिसकेका हुन्छ यो रिजल्ट प्रुभ गर्ने बेलाको लागि. सो इन्टिग्रेसन पार्ट भइसकेको छ. यो रिजल्ट कसरी युज गर्ने? हाउ टु फाइन्ड आउट लेन्थ अफ दिस लूप, हाउ विल यु युज दिस रिजल्ट? आई एम जस्ट आस्किङ दैट. यसमा के चेन्जेस गर्दैन दैट यु विल गेट द लेन्थ अफ द लूप?
2 times s for x equals to a, y equals to 0.
Exactly, हैन. एकचोटि x को ठाउँमा a, y को ठाउँमा 0 राख्न छ. You are going to get s will be length from origin till this point. यहाँसम्मको लेन्थ आउँछ तिमीको, हैन. and then multiply the result by 2 and you will get this expression 4 by 3 root 3a. Okay, so that's what you are going to use this that's how so the first step ma hamle your result prove garnu paryo and then entire length. So I'm going to do one thing. I'm going to minimize this screen. Just all of you go through this solution part. Quite easy. Integration matre garne ta hune, but before I show you that, let me ask you. S is length from origin to any point x comma y. So what limits of integration when you are calculating will be s?
0 to x.
Very good. 0 to x only. किनकि तिमीको change in x के भइरहेछ 0 देखि x सम्म. So now let me show you whole process. यतिको minimize गरेर देखिन्छ सबै कुरा. Can you all see this? Okay, here you can notice that this blue, whatever is written from blue, is the value of y in terms of x. Okay, y लाई चाहिँ x को टर्ममा replace गरेको. You have to just keep this in mind. Okay, ठीक छ हेऱ्यो कतै डाउट anybody having any doubt okay so simple integration छ integration गरेपछि this is how you are going to prove भइसक्यो yes Abhishek Subedi
Yes, ma'am.
okay बुझ्या छ कि छैन
Ma'am, म त हेर्दै थिएँ बिचमा पुगिरहेको छु
बल्ल बीचमा पुगेछ
टाइम लाग्छ म्याम
okay okay what about Anjula Adhikari Anjula
Yes, ma'am. Moving last year.
Last. Okay. Have you gone through your files? I've already uploaded these notes. Okay. तिमीको मैले नोट्सहरु सबै अपलोड गरिसकेको छु you can cross check right now also make sure that you have received these files छैन भने do let me know I'll upload it in your teams मैले normally सबैको म गरेको नै हो तिमीको by mistake छुट्यो कि just go through it okay you all make sure Okay, so done. हेरिसके सबैले next part we have already discussed. Okay. कसैले डाउट छ भने भनिहालौँ है. Now I will show you that this question is exactly similar to your previous one. Exactly same as your previous one. So prove that the loop of the curve and तिमीको यसपछि क्लास छ? विशाल? Do you have class right after this?
Computer class, no, ma'am.
Okay, so this is your curve. It's given in parametric form x equals to t square, y equals to t minus t cube by 3 is of the length 4 root 3. हामीलाई के भनेछ यो 4 root 3 length को curve हो. So what are we going to do? I'm going to show you that this is exactly same as previous question because we are going to first of all convert it to Cartesian form. The Cartesian form convert garनको लागि I've started with y. Y is given equals to this. I know you can just say check कसरी conversion by. It's very easy. Conversion भइसक्यो and then you see अघि हाम्रो equation के थियो? Your equation was 3ay square equals x into x minus a square, x minus a whole square. This was your equation, isn't it? Yes. So you have done conversion. Conversion गरिसकेपछि you can see there is only one difference in these two equations. एउटा मात्रै difference छ नि. A को ठाउँमा 3. That's it. A को ठाउँमा 3 राख्न सक्छ. You have got your equation. Okay. So तिमीको curve पनि definitely exactly same छ. Only what is the difference is? Only your difference is your a को ठाउँमा 3 त तिमीको limits of integration when you are looking for loop of the curve, यहाँ चाहिँ हाम्रो अघि prove गर्नुपर्ने थियो. Here we don't have to prove any such thing. We have to just find out length of the loop. So we will take limits of integration from 0 to 3, change in x, 0 to 3, and then you will integrate as you have done before. Previous question ma jasari garecha त्यसरी नै integration गर्ने, and you have got your result. Okay, so I'm leaving it here. Any doubts, please ask.
म्याम हजुरको भोलि कुनै पिरियड खाली छ कि छैन?
हाम्रो फर्स्ट पिरियड डिसाइड भएको छ नि विशाल हैन?
विशाल अहिले एब्सेन्ट छन्. भोलि फर्स्ट पिरियडमा हुन्छ एउटा एक्स्ट्रा क्लास.
भोलिलाई फर्स्ट पिरियड डिसाइड भएको छ. अरु पनि केही छ कि मैले हेर्नु पर्छ है.
हस् हैन मैले
कुनै
थाहा
कुनैमा
थिएन.
कुनै कुनैमा कोर्स पनि
एक्स्ट्रा क्लास गरौँ भनेर.
छ फर्स्ट पिरियड डिसाइड भएको छ मन्डेको लागि. अनि कुनै अरु क्लास पनि छ भने ल्याउँला हैन. हाम्रो